Okay, several of you came to me acting about the the ratio example from yesterday. It's a different format than you might be used to. So on the left-hand side is the instructions. On the right-hand side, right here, is an applet which we'll actually be able to use later on. So first of all, let's go up here and click. We have the warm-up, and then they have a problem. They said you could find each product. You can find each product mentally. I know you can hear everyone in the background at my house. So I was trying to find a quiet time. Not going to happen. So if we have 6 times 15. So we have 6 times 15. You can sit there and say 15 times 6. 30. Carry the 6. 6. Carry the 3. 90. You can also do it as the box method. Or as I call it, the area method. So I have 10 and 5 is 15, 0 tens and 6 ones is 6. So 0 times 10 is 0, 0 times 5 is 0, 6 times 10 is 60, 6 times 5 is 30, we add them across, that's 90. So that's possibly the two best ways to use it. That's the way we've done it before. If we notice on here, they have several other ones. I'm not asking you to do them mentally, but you can do them any way you want to do it. So if we have 12 times 15, remember there's 2 lines, so we put those 2 lines down here. 5 times 2 is 10, carry the 1. 5 times 1 is 5, plus 1 is 60. Remember we put our place marker here. 1 times 2 is 2, 1 times 1 is 1, and then we have 0, 8, 1, 180. And if we do it in the box method, or the area model for multiplication, which is some more technical term for it. So we have 10 and 2 is 12, 10 and 5 is 15, 10 times 10 is 100, 10 times 2 is 20, 5 times 10 is 50, and 5 times 2 is 10. So if we add these together, 20 plus 10 is 30, 30 plus 50 is 80, plus 100 is 180. So those are the warm-up activities just to practice some multiplication. So they have several of those. And if you notice, this says 4.1 is a warm-up, and it doesn't match up with 4.2, so we're not using that yet. So now we go to the next question. Hello, can it go? There we go. And then it says things like, let's share and discuss the work. Now, if we were in class, we would share and discuss the work. But either way, you can kind of sometimes just look at it. Do I have anything to add on the strategy? Do I solve it a different way? This is more if you're talking to a friend. So if you are talking to a friend about the assignment, you can kind of talk about, oh, I use the traditional method, the traditional algorithm, or I like to use the box or the area model. But this would have been done in class if we were together. So now I'm just going to skip over that one. It's just questions that make you want to think, is there another way to do it? So now you see you have activity 4.2. It says turning green. And then over here we have 4.2. So now these two are connected. So if we go on to the activity prep, it says in this activity we'll be mixing different colors by following recipes. We'll do some observation comparison. Finally, we'll discuss our work as a class. Again, if we were together, we would discuss our work. If you are talking to other friends while they're doing this, then you can discuss it with them. So then we go to the next. And it says, your teacher mixed milliliters of blue water and milliliters of yellow water in the ratio 5 to 15. Okay, so we come over here. We can say, okay, she did a ratio of 5 to 15. And remember when we did ratios at the beginning of the year, one of the biggest things we said we have to label it. So the 5, because it's tied to the first thing listed as blue water, that would be blue. And the 15 is yellow. So you can actually go over here and try it out. We can sit there and say 5 blue. Where's my mouse? There we go. 5 blue and 15 yellow. 5, 10, 15. Okay? So that obviously turned it green. That did work. Now the questions they say, doubling the original recipe, draw a diagram to represent the amount of each color that you will combine to double your teacher's recipe. So remember when we were doing equivalent ratios, they're the same as equivalent fractions. So I have 5 over 15. It's always easier to do it, I find it easier to do it this way. Blue to yellow. And if you're going to double it, that means you're going to times it times 2. So we're timing both by 2. So this would be 10 to 30. So then we can sit there and go over here and we can try it out because it's applet, we can reset and everything. So remember, it's 10 blue and 30 yellow. So 10 blue and 30 yellow. 5, 10, 15, 20, 25, 30. Okay? So those should be the same color. You just double the ratios. So it's finding equivalent ratios like we did before, because if you say that the ratio of 5 to 15 is what the teacher had used to find blue to yellow, made green, if you wanted to make twice as much, you would just double it. Use a marker to label an empty cup. Obviously, you don't need to do that double batch. You showed it right over here. So there's your work. And you can actually take a picture of that if you want to send it to me, or you could have done work like this. Now predict whether these amounts of blue and yellow will make the same shade of green as your teacher's mixture. Now we've done all that together. It's kind of like doing everything together. Is the ratio of your mixture equivalent to the ratio in your teacher's mixture? Explain the reasoning. So all right, let's reset this because we can make green in any way. So we're going to reset this one and reset this one. So let's just, you can try it wherever you want. So maybe you're going to say 10 blue. Okay, so that's kind of green. We're going to add 5 yellow. I'm going to get 5 more yellow. Okay, so then my ratio of blue to yellow was 10 to 10. It was 10 cups of blue, 10 cups of yellow. It still made green. So if I want to double that, times 2 times 2, 20 over 20. I would just sit there and say over here, I'm going to do 20 blue, 5, 10, 15, 20, and 20 yellow, 5, 10, 15, 20. And it makes the same green. So you could try that for anything you want to. I say play around with it, try to use your own recipe, and that's what you're going to show me. You're going to show me your own recipe and how they can make equivalent ratios, which is the same as equivalent fractions. So say if we said our ratio was 7 blue, let's see how much yellow we need to make. So we reset this, we have 7 blue, 5, 6, 7. So obviously it's blue. Let's try the yellow, 5. Well, that turned to green. So the ratio for this recipe will be 7 to 5. 7 over 5. If we doubled it, it would be 14 over 10. So that's how you find equivalent ratio. So from over here, we said 14 blue to 10 yellow, 5, 10, 1, 2, 3, 4. And then yellows 5, 10, they should be about the same color. So it's just showing you that when you have the same, when you use a ratio of a quantity, if you need to double it or triple it, quadruple it, you need to keep the ratio the same. It goes back to the original ratio. 7 to 5 was the original ratio. In order to make twice as much, we'd have to use 14 of the blue, 10 of the yellow. Okay. I know this is a long video. So now it goes on to tripling the original recipe. And again, that's easy to do. If original recipe was 5 to 15, if you're tripling it, 5 over 15 times 3 times 3, that'd be 15 and 45. So if I reset this and I said the first ratio was 5 to 1, 2, 3, 15, then over here, if I'm going to triple it, I'm going to go 1, 10, 15, and over here I'm going to do 45, 5, 10, 15, 20, 25, 30, 25, 30, 35, 40, 45. So that would be tripled. The recipe is the same color green. So that's all that's going over is that if, then again, with the empty yellow cup, you don't have to do an extra empty yellow cup. You could reset these batches and use your own recipe. It's basically showing about equivalent ratios. And then if you go to 4.2, there's other things. Draw a diagram to represent the amount of each color you'll combine. Again, if you take a picture of what you did, that's fine with me. If you write it down, that's fine with me. You're not going to be mixing anything in real life right now. Trust me, I don't have any colored syrup at home, so I don't think you guys do either. But basically you're finding out if it's equivalent ratios. Is your ratio used in this recipe equivalent to the ratio in your teacher's mixture? Okay, so if I had a ratio of 7 to 5, and I tried to find out if it's equal to 5 to 15, which is the teacher's original, this is yours. If you want to find out if they're equal, there's two different things you can do. One is you can cross multiply to see if they come up with the same things. This is 25, 15 times 7, 5 carry 3 is 105. So therefore, they're going to be, those will be equivalent. Those will not be equivalent. So if we did it over here and we said 7, 5, 6, 7 of the blue and 5 yellow, and over here we sit there and say 5 blue, 15 yellow, 10, 15. Those are completely different colors, so you would not get the same ratio. So again, if you want to hand it in like that, like taking pictures and screenshots and sending that to me, that's fine. You could write it on a piece of paper, take a picture, so you can show me what you're doing. Obviously, do a better job of labeling than I did. Now again, this was sharing the ratios with group members. If you guys wanted to find out with each other, you can do that, but it's really not something that you're going to be doing. Activity Perfectly Purple Water. And then it says like basically you're going to work in pairs to make purple water. Then we'll create a new mixture to make perfect purple water. Finally, we solve our ratios. Now, you're not going to be, you don't have to do that because we can't do it physically. So this, you could just find equivalent ratios, because if it was 5 to 15 made purple, then obviously if you tripled it, it'd be 15 to 45. It's tough with this online stuff because some things I'd have to say, click, separate this. So 4.3 activity, as for blue and red, again, we're not doing it on this because this is blue and yellow. But if she did, I'm running out of paper, clean paper. If it was 8 blue and 3 red, and you want, and Jada mixes 24 blue and 9 red, one way you could look at it is sit there and say, well, what times 8 is, sometimes times 8 equals 24. Yeah, okay, that's times 3. And 3 times 3 is 9, so these would be equivalent ratios, and it also would make the same exact color, because the only way to make the same color, tripling it or doubling it, is to make equivalent ratios. And then you could find another ratio, but again, we can't really do that in class. And then let's share our ratios. We can't share with each other, but you could if you want to start a conversation on the lesson. You can do so. And then this is just more practice. Like, how do you decide that 2 milliliters blue and 30 milliliters yellow would make 2 batches? Well, is there equivalent ratios? And you multiply it times 2. So that's what you would be looking at to answer those questions. And the cool down is always just another way to answer the questions. And if you write a ratio of 2 batches of the recipe, again, that's making equivalent ratios, just like we did before. So the ratio is 3 to 1, and then you would have to double it, or 4 batches. Explain why we can say that any 2 of these ratios are equal, because you're doing the same thing to the ratio. And then those are the lesson targets, and then you're done. So whatever work you're doing, you can send to me. You can create a new document and do the work that way. But we want to label it. So like I would have to sit there and say that, like, this is the warm-up. And we can sit there and say this was the ratio for green. And you can sit there and say, like, this is the teachers, and label it so we know what you're talking about. Okay? Hope you guys have a great rest of your day. I'll try to do a few more tutorials that are shorter than this for the next few lessons, because we're still doing ratios next week. But I want to make sure everyone's on iReady. It's very important that you're on iReady and Reflex. I am tracking your usage, and if it falls below, then we're going to have some discussions. I'll call, I'm calling your houses, so I'll call your houses and we'll talk about what we can do to make sure that you can get all your work in. All right? Have a great weekend, guys. Bye.